Good morning, class. This is Mr. Eggleston. This is Algebra 2, Quiz 7.1 through 7.4 review. So simplify each expression. I want you to write your answer in standard form. So the first problem, we're adding. The second problem, we are subtracting. So I would highly recommend just quickly right underneath rewriting each polynomial into standard form, which will help you to make sure you add the right things together. So notice I'm just reordering the first polynomial. Notice I started with the highest power of n to the fourth, then n cubed, then n squared. Then we're going to add, now I have to shuffle the second one, that's 4n to the fourth, plus 4n cubed, plus 5n squared. Now that they're in standard form from highest power to lowest, it's really easy to be able to match up the highest powers. So we combine negative 6n to the fourth plus 4n to the fourth. Negative 6 plus 4 is negative 2n to the fourth. Then our next highest is 2n to the third plus 4n to the third. That is 6n to the third. Then lastly, we have 4n squared and plus 5n squared, which is 9n squared, and that is the sum of those two polynomials in standard form. All right, the next one is we're subtracting. So what I would argue is, again, reorder and make sure both polynomials are in standard form. So the highest power on the first one is m to the fourth. Then it'll be plus 5m cubed. Then it'll be minus 6m minus 8. And then minus, I would again put the second polynomial in standard form, 6m to the fourth plus 2m plus 8. Now we're subtracting. This is always a little bit trickier. When you subtract, you add the opposite. And I would highly recommend that what you would do is turn subtraction into addition by flipping the signs of the second polynomial. Now you don't have to worry to remember, oh, I got subtract instead of add. So we got 6m to the fourth plus 6m to the fourth. That's 12. That is 12m to the fourth. Then we have a 5m cubed. There's no m cubed over here, so there's nothing to add it to. So it just comes along. Okay. And then we have negative 6m minus 2m is negative 8m. Okay, and then finally we have negative 8 plus negative 8. That's not 0, that is negative 16. And that is the difference between those two polynomials. All right. For question number 3, write an equation for a fourth degree polynomial with x-intercepts of negative 2, negative 1, 3, and negative 4, and has a y-intercept of 0, negative 24. So this is fairly straightforward. I'll use f of x notation. We'll have a, the stretching factor, and then our first factor will be x minus a negative 2. That's the first 0, which makes that x plus 2. And then we'll have x minus a negative 1, which turns into x plus 1. And then we will have x minus 3. And lastly, x plus 4. Fourth degree polynomial, and notice we have 1, 2, 3, 4 factors. Now the only thing we don't know is a. So they gave you a point, which happens to be the y-intercept. When x is 0, y is negative 24. So let's use that. So we got negative 24 equals a times 2 times 1 times negative 3 times 4. Notice when x is 0, I just ignore the x's and keep the numbers. So 2 times 1, use a calculator if you don't trust yourself. 2 times 1 is 2, times a negative 3 is negative 6, times 4 is negative 24. So we have negative 24a equals negative 24. Divide both sides by negative 24 to solve for a. Sorry, you don't divide by negative 24a, you just divide by negative 24. And then you have a equals 1. So, all right, so what we're going to do is take the polynomial we wrote down and replace the a with 1, which just basically means we can just kind of erase it, because if it's 1, it's like that, and this is your answer. You could also put a 1 here if you wish and circle it. So there you go. All right, notice it said leave in factored form, so you don't have to sit there and multiply it together. Next up, which of the following could be the degree of the polynomial shown? All right, you got 1, 3, 2, and 4. So looking at this, we know right here that's a multiplicity of 1. So x minus 2 shows up once. Right here at x equals 5, it bounces, so that's a multiplicity of 2. So 1 plus 2 equals 3. So the degree of the polynomial is shown could be degree 3. Notice degree 3 is odd, which means as you go to the right, since the leading since it goes down to the right, that tells you what the leading coefficient is, it's negative, it's doing the opposite to the left. So that also signifies an odd power. And that's number 4. All right, moving on. A third degree polynomial function has a leading coefficient of 1. Two of the function's zeros are given. 5 and 3i. Write the equation. It says write an equation for the polynomial in factored form. So you don't have to worry about a. I'm just going to assume they said leading coefficient of 1. So that's a is 1. So f of x is going to be x minus 5, x minus 3i. And since that's an imaginary 0, okay, that means its conjugate, which is negative 3i, has to be also 0. So that makes it cubic. So this will be x minus 3i and x plus 3i. Now, that's the factored form, that's a. Actually, since we want real coefficients, we do have to get rid of the imaginaries by multiplying those two together. So this is just a sum difference of squares. First x times x gives you x squared. Watch the beauty of this. And then you have negative 3ix plus 3ix. They cancel out, and you're left with negative 3i times 3i, which is negative 9i squared. Okay, so in factored form, this would be x minus 5, and I squared is negative 1. So that's x squared plus 9. This is factored form. There are no imaginary numbers showing up in this. Notice the imaginary zeros of negative 3i and positive 3i turned into x squared plus 9. Okay. Then they want you to write it in standard form or general form. So B, you multiply together x minus 5 and x squared plus 9. You just actually literally multiply together. So going through the FOIL process or distributed process, you could also make a box. X times x is x times x squared is x cubed. That's x times x squared. X times 9 is 9x plus 9x. And then negative 5 times x squared is negative 5x squared. And lastly, negative 5 times 9 is negative 45. Okay? Restructuring and reordering, putting this into standard form or general form, x cubed go minus 5x squared plus 9x minus 45. And this is the product right here. That's the general form of f of x. Okay? These two are the same. Now, sorry about that. Okay, what is the y-intercept of f of x equaling this expression? Well, that's easy. The y-intercept occurs when x equals 0. So they're really asking what is f of 0. So if you plug 0 in, you get 5 cubed from the first factor, negative 2 squared from the second, and positive 2 squared from the third factor. So we have this. So we have 125 times 4 times 4. 125 times 4 is 200, right? Because 4 times 100 is 400. 4 times 25 is 100, that's 500. Times 4, which is 2,000. Okay? So the y-intercept is at 0, 2,000. Again, all you had to do was plug 0 in to find, for x, to find the y-intercept. All right? Finally, describe the end behavior. All right, the end behavior means we want to look at what happens as the limit, or not the limit, see, I'm going into calculus mode. We want to know the behavior of f of x as x goes to negative infinity, or the left. And then we want to know what happens to f of x when x goes to positive infinity, or the right. This is the left or the right. So we look at the degree. And also, all we care about is the highest power. The highest power is 4. It's an even power, so that means whatever it does to the right, remember, highest power equals even. Right and left do the same thing. Okay, so, and also since the Lie coefficient is a positive 1, the Lie coefficient tells you what it does to the right. So it goes up to the right. That's because Lie coefficient, the number in front of the highest power, equals a positive, because it's just x to the 4th. And now we know going to the left, it also goes up, okay? Because it does the same thing, because it's an even power. If this had been like x to the 7th or something, then they would do the opposite. If the right goes up, the left will go down. But since it's x to the 4th, if the right goes up, so does the left. Then the last one is write an equation for the polynomial shown. Include any multiplicities. Note the y-intercept is 0, 10. So looking at this, you see you have an x-intercept right there, an x-intercept right there, and right here. Both of these are multiplicities of 2 because they bounce. This one is a multiplicity of 1. All right, so the equation would be y equals a. They want a specific, unique equation because they give us the y-intercept. And it'll be x, that was at -4, so it'll be x plus 4 times x plus 1 squared and x minus 5 squared. The reason they're squared is because at those points, the graph bounces. So there's your basic equation. The only thing we don't know is a. They tell us a is 10. Or not a, but y is 10 when x is 0, because that's the y-intercept. So that means it's going to be 4 times 1 squared times a -5 squared, which equals 4 times 25, which is 100. A. All right? There's this a still multiplying it. Okay? So a equals 10 over 100, which is 1/10. And then you just replace a with 1/10, or you can say 0.1, and you have your unique equation for that polynomial. Okay? And that's it. 8 questions. Not too shabby. Talk to you soon. If you have questions, come see me before Thursday or Friday, whenever your quiz is. All right? Thank you. Bye-bye.